Determinant of a matrix of order 1. Welcome back, everyone. In our previous lesson, we established the fundamental concept that a determinant is a unique scalar value, essentially a single number, that is associated with any square matrix. Now, as we move forward into the practical side of things, we need to learn how to actually calculate this value. To make this transition smooth, we are going to start with the simplest possible case, a matrix of order 1. By mastering this basic building block, you'll find it much easier to tackle more complex matrices later on. Understanding the $1 times 1 matrix. Now that we've established that a determinant is a unique scalar value, let's take a closer look at the simplest possible structure we can work with. When we talk about a matrix of order 1, you might also hear it referred to as a 1-by-1 matrix. Essentially, it is a square matrix that is as minimal as it can be, consisting of only a single row and a single column. Because there is only one row and one column, it follows logically that the matrix contains exactly one single element. To be precise with our notation, if we have a matrix named A of order 1-by-1, we represent it using square brackets containing the element a sub 1-1. In this notation, the subscript 1-1 tells us exactly where to find our value. It represents the element located at the intersection of the first row and the first column. This single element is the only piece of information we need to focus on for this specific case. The rule for calculation. Now that we have defined what a 1-by-1 matrix looks like, you might be wondering how we actually perform the calculation. The good news is, for a matrix of order 1, the process of finding the determinant is incredibly straightforward. In fact, there is no complex arithmetic involved here. The determinant of a 1-by-1 matrix is simply the value of the element itself. To put this into mathematical terms, if we have a matrix A, represented by a capital A with square brackets containing a lowercase a sub 1-1, then the determinant of A, which we can denote using vertical bars as absolute value of A or as det A, is simply equal to a sub 1-1. In short, the value inside the brackets is your answer. Step-by-step process to find the determinant. Now that we have established the rule that the determinant is simply the value of the single element itself, let's break this down into a clear, step-by-step process so you can approach any problem with confidence. First, you need to identify the matrix. Before you start any calculations, take a moment to verify that you are actually dealing with a square matrix of order 1-by-1. This means you should see only one row and one column. Second, once you've confirmed the order, your next task is to locate the element. Look inside those square brackets and identify the single numerical value contained within them. Finally, you simply assign the value. There is no complex multiplication or subtraction needed here. The value of that single element is, by definition, your determinant. It sounds almost too simple, doesn't it? But as we will see in our next slide, even in a real-world scenario like asset valuation, this straightforward rule is exactly what you'll apply. Real-world example, single asset valuation. Now that we have mastered the rule and the step-by-step process, let's look at how this applies to a real-world scenario. While you will often see determinants used to solve much more complex systems involving many variables, a 1-by-1 matrix is perfect for representing a system that has only a single variable. To illustrate this, let's imagine a scenario. Suppose a company is tracking the market value of a single, rare collectible item within their digital inventory. Currently, the market value of this item is $5,000. We can represent this single piece of data using a 1-by-1 matrix, which we will call V. Let's walk through the calculation using the steps we just learned. First, we perform step 1, represent the data as a matrix. We place our value inside the square brackets, so V equals the quantity 5,000 enclosed in brackets. Next, we move to step 2, apply the determinant rule. As we discussed in the previous slides, because this matrix V contains only one single element, finding the determinant is incredibly straightforward. The determinant of V, which we write as the absolute value of V, is simply equal to 5,000. In conclusion, the determinant of our valuation matrix is 5,000. This simple example shows that the value remains unchanged, but it's important to keep in mind the distinction between the matrix itself and its determinant, a common pitfall we will address in the next slide. Common mistakes to avoid. First, be very careful not to confuse the matrix itself with its determinant. It is easy to look at a matrix, let's say, A equals the element A inside square brackets, and think it is the same as the determinant. However, you must remember that the matrix, represented by those square brackets, is essentially the container holding our data. The determinant, on the other hand, is the specific numerical value we are looking for, which we denote using vertical bars, or by using the notation det. Keeping this distinction between the container and the value clear is crucial as we move into more complex matrices later on. Second, try your best not to overcomplicate the process. As you progress in your studies, you will encounter higher-order determinants, such as 2x2 or 3x3 matrices, which require much more intricate formulas and calculations. Because of this, beginners sometimes feel the need to apply a complex formula to a 1x1 matrix. But as we have seen in our previous slides, there is no need for any calculation here. For a matrix of order 1, the element itself is the answer. Now, before we wrap up our lesson, I want to pause and highlight some common pitfalls that students often encounter when first learning this concept. Keep these points in mind as we move to our final summary of the key takeaways. Key takeaways. To wrap everything up, let's review the key takeaways from today's lesson. First, remember that a 1x1 matrix is the most basic and simplest form of a square matrix you will encounter. As we saw in our earlier slides, it consists of just a single row and a single column. Second, the rule for finding the determinant is incredibly straightforward. The determinant of a 1x1 matrix, where A equals the element A sub 1,1, is simply that single element, A sub 1,1, itself. Finally, keep an eye on your notation to avoid the common mistakes we discussed. If you have a matrix A equal to the element A sub 1,1, you would write its determinant as the absolute value of A, which equals A sub 1,1. If you can master this fundamental concept, you'll have a solid foundation for the more complex 2x2 and 3x3 matrices we will tackle next time.